Okay guys, this video is for Honors Algebra 2, 6-2, inverse functions and relations. So this video starts with a couple of text boxes here with definitions and key concepts and stuff like that. The first one's talking about with inverse relations. If you have two relations that are inverse relations, if and only if whenever one relation contains the elements a comma b, the other relation contains the elements b comma a. So basically what it's saying is if you have two relations, the order pairs are flipped. So A is 1, 5, 2, 6, 3, 7. B would be 5, 1, 6, 2, 7, 3. Notice the set notation for those. That's in essence what an inverse is. It's just you kind of flip out the order pairs and boom, there's your inverse. Now because of that, you have the bottom box, the properties of inverses. And so we're going to quickly go through this one here. If f and f to the negative first are inverses, then f of a equals b if and only if f inverse of b equals a. So the example of this is here. Let f of x equals x minus 4 and represent its inverse as f to the negative first. That's how you denote an inverse. You say it f inverse, not f to the negative first power, but so it's f inverse of f of x equals x plus 4. So the first thing they say, all right, let's evaluate a number, so they pick 6. So they plug 6 into f, they get 6 minus 4, which is 2. Cool. Then they say, all right, let's do the inverse of 2. So they plug 2 into the f inverse function, they get 2 plus 4, which is 6. So you finish where you started. So you started with 6, you plug it in, you get the middle number, you spit a number out, you get 6. And so since that's the case, it's going to be like that every time. F of 6 equals 2. And f inverse of 2 is going to equal 6 every single time. Since you know that now, then you're going to be asking the ACT to find inverses. So not just necessarily, do that part to it, but also find out what this function's inverse is. So there's 4 steps to it. They're pretty simple steps. First one being write an equation, or write the function as an equation with x and y. The second one being exchange x and y. We'll show you that in a sec. Third step being solve for y. And then step 4 being rewrite in function notation. So let's do one here. We have find the inverse of 2x minus 5. So the first thing we're going to do is rewrite it as an equation with x and y. So basically replace f of x with y, like so. Alright, step 2 says exchange x and y, so we're going to flip-flop x and y spots. So it's going to be x equals 2y minus 5. You don't move the 2 with the x, you just move x and y, that's it, everything else stays constant. After that it says solve for y, so that could be multiple steps depending on how complicated a function you have. This one we have 2 steps to do, the first one being add 5. And the second one being divided by 2. And then the last step says rewrite in function notation. So since it is the inverse of f of x up here, we're going to do f to the negative first of x, f inverse of x equals 1/2 x plus 5/2. And if you want to do the number guessing trick on here, I would always go with 0. Plug 0 in here, you get -5. And you go down here, plug in -5, you end up with 0. So that's one way you can always check yourself with these two. Now the next one's going to show you a little interesting fact of these. Whenever you work these out, find the inverse of f of x equals x squared plus 1. So same process. So y equals x squared plus 1. You literally switch x and y. So x equals y squared plus 1. You move nothing else. Okay, you don't move the squares. You just move the variables. That's it. And then you go again and solve for y. So you subtract 1 over. So x minus 1 equals y squared. And then we're going to undo that square power with a square root. So we get y equals, flipping the sides, the square root of x minus 1. Rewrite into function notation. F inverse of x equals the square root of x minus 1. Okay, that's part 1 of the lesson. We're 5 minutes in, which is pretty nice. Now part 2 basically is going to be, verifying inverses. And I want you guys to pay attention to this part here. Yes, you can do the number trick. My goal for these questions is to get you guys more practice with doing compositions of functions. Okay, I think having the algebra skills to know where you plug in different numbers is very important. So I want to make sure you guys understand that whenever we do these types of problems, I want to see them done the way you're being taught here, not just guessing yes or no, checking, whatever. If I don't see the work, you don't get the credit, plain and simple. So basically what you can tell is if they're two functions, then the inverses, or if two functions are inverses, then their compositions both ways are going to simplify down to x. So f of g of x will be x, g of f of x will be x. And that's what I want you guys to do, because I want you guys to have more practice with doing compositions of functions, because it is honestly one of the more prevalent things that are on the ACT, prevalent topics. So f of g of x here, when f of x is 3x plus 9, g of x, is 1/3 x minus 3. So determine whether each pair of functions are inverse functions, so you're going to find both compositions. So f of g of x over here, g of f of x over here. So we're going to find f of 1/3 x minus 3, which is going to be 3 times 1/3 x minus 3 plus 9. Okay, distribute the 3, so you get x minus, I don't know what's going on here today, minus 9 plus 9, and that simplifies down to just x. So that you're looking good there, but you have to do both. Okay, so double check the other one, make sure it's also going to simplify down to x. So you have g of 3x plus 9, which plug it in, gives you 1/3 3x plus 9 minus 3. Distribute the 1/3, you get x plus 3 minus 3. So you get x as well. So are these inverses? Yes. Okay, so this one here, determine whether each pair of functions are inverses or not, so we're going to do the same thing. F of g of x, and then g of f of x. So f of g of x would be, f of 2 square root of x. So we're going to plug that in to f, which is going to give us 4 times 2 square root of x squared. So 2 rad x times 2 rad x gives you 4x, and then 4 times 4 gives you 16x. And that's all the simplifications you can do. So once you get down to verifying that you cannot get it to be simplified to just x, you can already put not inverses. And you don't have to show the other way. If you can prove it one way, you don't have to show the other way. So that's kind of nice. So once you figure out one's not going to simplify to x, you don't need to worry about trying to get the other one down to nothing x, because it's probably not going to get down to x. Okay, the last one, determine whether each pair of functions are inverses. I'm going to go ahead and let you guys try this one. Put in your answer and then see how you did. Alright, so are these two inverses? Yes, they are. You have f of g of x over here. So you have f of the square root of x plus 1 all over 2. You plug that into f. So 2 times that quantity, you square it, gets rid of the radical. multiply it by 2. These 2's cancel, so you're left with x plus 1 minus 1, so it means you're left with x. On the other side, you do g of 2x squared minus 1, plug it in to g. So you have the square root. I should fix that, make it look like the square root of the whole thing. There it goes. So 2x squared minus 1 plus 1 all over 2, all underneath that square root. And so you have like terms up top, so at minus 1 plus 1 gets them gone. So you have 2x squared over 2. These 2's cancel, so you're left with the square root of x squared, which is just x. So yes, these are inverses. As always, if you guys need help with anything, let me know. But your assignment's on page 396, 15 through 20, 27 through 32.